this tree data structure in C++, performing traversals on this one, and I'm only doing the Inorder traversal. And that is my assignment. Implement the Inorder traversal algorithm using C++, the one here. So I'll have to perform this. So I already did the manual traversals for Inorder, and this is the answer I got: BDHEIAFCG, and the algorithm says left, root, right. So let's see how we can implement this in C++. So let me delete this. I already made a boilerplate for C++. So my first task is to create a class. I'll call it node. So I also checked out a struct. I can use a struct. However, I've learned the advantages of using a class. A class has more advantages compared to a struct, and this is why I'm going to stick with a class. Struct by default is public, but a class by default is private. For that reason, for me to be able to access my variables, I need to specify with the public keyword here, and then down there I can access all the variables. So I'll say public, and because I am accessing these variables, that is A, B, C, D, all the way to G, that means my, that means my variable data types have to be string. So the first one, I'm going to name it data, that is for root. So string data, and then I'm going to create a node pointer variable for left, and another node pointer variable for right. So my variables. So variables in a class, they're called attributes, and a class also takes in methods. Methods are basically functions inside a class. So this is my first function. I also call it node. So node, and then the parameters, I'll take the data type has to be string, and I'll also name it data. Okay. This is the body of my function. If you've noticed, my class variable, the first one here is data. Inside my node variable, it is also taking data. And to resolve this, I'm going to use the this keyword. So I'll say this dot data is equals to data. I can use a different word here, but I don't want to confuse myself as I call the value of this later in my program. So now what is happening is this data is of this string variable, and then this data now is of the node. It belongs to the node, my function. Okay. Now my node is not done. I need to equate left to something, and they will be equated to now. And then I'll also do the same for right. Actually not equated to now, they are assigned to now. So my first task is done, and my task is I don't need all that. So my task is or the first part is creating a node. So I've created a node. Now all this class is a These are constructors or a building block, or you want to create later in your program. So now I've created my class and it has its methods and attributes. And now I'm going to create a function. This is the function that I'm going to turn into a recursive function. It should be named according to what you're building. So I'm doing an in-order traversal. So I'm going to name this function as in-order traversal. Okay, in-order traversal. That's a function call, and this is the body. Okay. Here in the parameters, I have to it is able to access node or the root node. So this is another pointer variable. I'll say okay, and I haven't created this yet. Now for me to make it a recursive if statements, since a function has the base case, then it has return or recursive calls, then the return value. So for now I need a base case, and to do that I'm going to use an if statement. So inside here, so that where will be my if root is not equal to it will perform what I'll put here. It will do the traversals. So if root is not equal to null, in this case I've equated everything to null, meaning if it's equal to null it will just return. If it is not equal to null, it will perform the traversals. So here I'll call my first recursive, simply calling the same function. So in order, okay, that one, in order traversal. Inside here, if root is not equal to null, then it will start traversing. So since here root is not equal to null, it is A, so it will move this side to B. So if root is not equal to null, then dot left. Let's see. It's not equal to null, then I need to find left. Yeah. Root dot left. What else? A recursive function should take a return value. So I need a return value. And my return value is basically a cout. So cout has to be like this. So cout root dot data, just like that. This is why I wanted this variable and that to be named data, so that I'm not confused. So here root.data, but actually data is root. So root.data. If the case is not met, then I need another recursive function. Oh, sorry, not a recursive function, but a recursive call. That's what I'm doing. So another recursive call here in order. So in this time, since I've already done root.left, I'm going to do root.right. Okay. So I'm done with the function. Now inside this function is outside the class but not inside the main function. So now inside the main function, I'm going to create a node. Create a new node. Maybe I can comment it here. So create and to do that, I'll simply call node. Sorry. Root is equals to new node. It is of a string data type, meaning I'll pass the values here. Okay, so this is my root node that belong to class node. Okay, so here I have a, meaning root is not equal to now, it has this value, so meaning traversals have started. So root dot to go left, root dot left is equals to new node. Okay, root dot left from A to B. So here I have B. Not there. Okay, there. The next I need root dot, again still left, root dot left. Actually this time it's going to be root dot left is equals to so why it's root dot left, because from root I've gone left then to access D. So here we'll put D. So we have D. Then I need root dot. So root dot left dot right to access D. Then this time we're going to access E. Already have B, so we're going to say root dot left dot right. Root dot right. This is equal to new node, and we're accessing E. I have this problem. Okay. Creating a new node. So actually here we are creating our tree. So we are creating the tree, the entire tree. And we're doing the left side. So I've reached on E, I need H. So this is root dot left dot right dot left. dot left dot right left to be able to access equal to new node, and this accesses letter H. Okay, and now I need to access letter I, so root dot left root dot left, is that left? Root dot right equals to new node, and here I'm accessing letter I. So side, okay, get the right side, that is get right side of the tree on right branch, right side of tree. Okay. Since now we are here, root dot right starts with root dot right. Root dot right equals to new node. New node. We have C. Okay. And then we need root dot right dot left. Root to new node. See, root dot right dot left, we have F. There goes our last node. Root dot, it's it first. Root dot right right to access G dot right equals to new, and this problem here, root dot right. There we go. We don't seem to have errors. Now we can print it out. So we have the left side, we have the right side, and we see out. We print out, see out. Here I'm going to say in all so let's put the end line there, and L, do the printing. Okay. So I call the function, that's the in order. Just call function call there inside. Okay, and we are done. So if everything goes well, it should be able to give me this output. Then the code is right. You see, right. DBHEIAFCG. Is it the same here? BDHEIAFCG. I think my code is alright, and this is the end of my presentation. I think I've performed the Inorder Traversal. Okay, and let me end my video there.